Welcome back for our conversation in this conference about climate change from space. Let's start our first panel. Understanding climate change is the subject because it's imperative to understand and repair the climate disruptions. We have to be rational, and climate change is an unresolved challenge. Most of the issues rely on data from space infrastructures that help us to understand the phenomena. Well, I would like to say that data and information is actually the key. We start with Patrick Child, our keynote speaker. He's Deputy Director General in DG Research and Innovation at the European Commission and leads the policy for implementation, impact and sustainable investment strategies. Patrick, welcome.
Thank you very much, and I'm very, very grateful to the Portuguese EU presidency for inviting me to this important and timely conference. And as Deputy Director General of DG Research and Innovation in the European Commission, I also have the honour this year to be lead co-chair of the group on Earth observations. And I'm therefore delighted to have this opportunity to address you today on three main issues. Firstly, space assets and Earth observation in particular, which are vital to help us address the climate challenge across Europe and the world more generally. Secondly, the role of research and innovation and the data, information and knowledge gained for it, which have critical roles to play in tackling these challenges. And with the European Union's Research and Innovation Framework Programme Horizon Europe, I believe we are well equipped to make a very major contribution. And third, recognizing that this is a global challenge requiring collective mobilization, I'd like to speak a little bit about the importance of international collaboration. So my first message is that Earth observation and our work in space can help us develop effective responses to the impacts of climate change. This is a core aim of the European Green Deal, to ensure that the climate transition is tackled in a holistic way, including through both mitigation and adaptation measures. And EU programs such as Horizon Europe and the EU Space Programme and Digital Europe will acquire and process Earth and environmental data, whether from space, from air, sea and land, or by data we gather from observations. And combined with other sources of data, for example on our health or meteorological data, we're able to assess the state of the planet and set priorities for our resources and actions. Monitoring forest fires and predicting wildfire risks are two examples of how space-based monitoring contributes to our preparedness for and response to climate-related disruption. The frequency and severity of extreme climatic events is likely only to increase, heightening the need for real-time observational data. Space data and Earth observation, we believe, will help in understanding the causes and mechanisms behind these disruptive events. And I can perhaps take an example recently of the flooding disaster in a very remote part of the Himalayas last February. With Copernicus satellite imagery, we were able to identify the immediate cause, a landslide, but also the deeper-rooted causes of the crisis, which were receding permafrost. And I believe that this sort of analysis can help us predict and prepare for similar events in future. In the aftermath of the COVID-19 pandemic, the same approach is informing our pandemic preparedness work through the creation of new research and innovation partnership, databases, and other initiatives. Digital solutions are helping us to improve understanding of climate risks and resilience options, bringing benefits for citizens, for example, in response to climate risks for health services, or facilitating adaptation through precision agriculture. The European Union's digital strategy seeks to harness the potential of European digital twins, cloud facilities, and artificial intelligence, among many other things, in support of this important digital transition. We are making significant efforts to collect data needed to design adaptation plans through large international Earth observation and in situ data programs. And we believe that it's important to strengthen our capacity to process data to deliver climate services to an increasing number of stakeholders and policymakers. And as we seek to raise our ambition in all these areas, I think we can build on an impressive range of European Union assets and policies, including, in particular, the Copernicus Climate Change Services and its climate data store, as well as the EC Disaster Risk Management Knowledge Centre run by our colleagues in the Joint Research Centre. And this, I think, brings me to my second key message, which is the importance of research and innovation at the heart of the climate transition. Under our Horizon 2020 research and innovation programme that finished last year, we would have invested nearly 1.5 billion euros in climate research and relevant space activities. This support has made a powerful contribution to strengthening European Union space infrastructures and services, as well as space products, services and applications. A good example of this is the Europe Horizon Prize on Early Warning for Epidemics, which we launched in 2018 with the aim of stimulating innovative solutions to problems that Europe citizens. This was intended to develop a prototype early warning system for vector-borne diseases, building on the monitoring of weather and climate change. As the recent COVID pandemic has clearly shown, we gain more insights by combining different fields of research with instruments, solutions and applications based on or coming from space assets. In this context, climate services are vital, providing user-driven development, translation and transfer of climate knowledge to researchers and decision makers in policy and business. Co-funded by Horizon 2020 and our European Union member states, the ERANET, European Research Area for Climate Services, is a network of 45 partner organizations from 18 European countries designed to boost the development of efficient climate services in Europe. And I'm really happy that the 26 projects selected under this ERANET make use of Copernicus data and services. One example of a collaborative Horizon 2020 project, ProSnow, helps us to save energy and water by producing responsible and resource-efficient snow, thanks to modelling based on observations. This service is now ready to be implemented commercially. And we will be building further on these investments under our new Horizon Europe Research and Innovation Programme. As our Commissioner Maria Gabriel has emphasised, with a budget of 95 billion euros for the period in 2027, more funding than ever before will be available for projects providing innovative solutions to the climate crisis, as well as biodiversity, environment and energy. And the first calls for proposals covering 2021 and 2022 will be launched within the coming weeks. And these will include, for example, specific space-related calls for proposals on satellite navigation, Earth and environmental observations. A novel feature of Horizon Europe will be missions, a portfolio of activities based around research and innovation goals, but also seeking to address broader mobilization of resources and assets to help solve pressing global challenges and real-life concerns for your citizens. And I'm happy to say that 4 out of the 5 first Horizon mission topics are linked to the European Green Deal directly, and therefore to our collective efforts on climate action. They will extensively use data and services provided by EU space programs to ensure that they reach their objectives. We've also, under Horizon Europe, revamped our approach to partnerships, industrial partnerships and with other actors as in the private and public sector. And one example of this is the globally competitive Space Systems European Partnership, which we believe will support the competitiveness of the sector and will reinforce EU capacity to access and use space. As with the Horizon Europe missions, we expect that many of the partnerships will benefit from observation data and services. Finally, under Horizon Europe, I want to talk about the importance of better involving small and medium-sized enterprises in research and innovation activities. This is a central goal of Horizon Europe and is reflected throughout the programme with our missions, our partnerships, as well as with the creation of the new European Innovation Council, which will have the specific aim of supporting breakthrough innovations in emerging and new markets. Working with a wider range of actors brings me to my third key message on the importance of international collaboration. And here I'd like to highlight the work of the Group on Earth Observation, which provides global solutions to planetary challenges. GEO is a partnership of more than 100 national governments and over 100 participating organizations. The European Commission is very pleased to be part of it. We seek through GEO to ensure that policy decisions are informed by coordinated and comprehensive Earth observations, making key contributions to our priorities for the Sustainable Development Goals, achieving the objectives of the Paris Agreement, and also on the Sendai framework for disaster risk reduction. GEO is building and operating the Global Earth Observation System of Systems, GEOS. This is a worldwide system which aims to use Earth observation data to improve the lives of citizens and help governments make good evidence-based decisions. And to implement this vision, GEO has divided the world into 5 broad regions, and Europe is one of these. And EuroGEO, the framework we have in Europe to combine the contributions of GEO members, is very active and makes a big contribution. Through EuroGEO, Europe is able to position itself as a global force in Earth observation, thanks to the vast knowledge gained through running, in particular, the Copernicus program and our other space and Earth observation activities. And I'm very pleased to say that this year, the European Commission is the lead co-chair of GEO, which gives us an opportunity to ensure a really direct connection between the European Earth and environmental observations through Copernicus and EuroGEO, and the broader framework of the Global Earth Observation System of Systems. And we will take this opportunity to focus on showcasing European examples and best practices on the global playing field, but also to exploit these assets offered by GEO and its members and look for deeper cooperation across the GEO network. Just to give an example, in Asia and Oceania, the nations are facing similar challenges in tackling climate change as we face in Europe. And we are working together with them to see how we can help with the knowledge gained in our respective regions, and in particular how we can bring the assets of Copernicus to the wider international community. Finally, one of our goals as lead co-chair of GEO is to enable and promote the access to and the use of Earth observations in pandemic epidemic responses and the future green and digital recovery that we so much want to see. So in conclusion, ladies and gentlemen, to ensure that we can face ongoing challenges and those ahead, especially linked to climate change and its related disruptions, I'm confident that the portfolio that we are developing of research and innovation instruments, allied with global cooperation and the further market uptake of space assets, provide a powerful route out of the current crisis and as we confront the big global challenges ahead. So thank you very much for your attention. I look forward to the discussion in this panel.
Thank you so much. Those are great news, and we have great expectations for the future that we can hopefully wait for us. Now, time to listen to Azeem Azhar. Hopefully I said it or I pronounced it right. He is the writer behind Exponential View, which explains how society and the political economy are changing under the force of technology. He brings a unique background to explain the intersection of breakthrough technologies and the economies and societies in which we live. He is also a member of the World Economic Forum's Global Futures Council on the digital economy and society. His first book will be published in summer of 2021. Well, this is the year. Congratulations, by the way, and welcome, Azeem Azhar.
Well, thank you. Thank you so much for the invitation, and also for propelling me into space, as I can see on this wonderful virtual studio.
You're floating. You are all floating, if you know, and you can breathe. It's extraordinary.
This is as close as I think I'll get for a while.
We don't know about that.
Thank you very much.
We don't know about that. Everything's possible.
We'll find out. Yeah, we'll find out. Good. Well, should I get going?
Yes, go for it.
Yes, wonderful. Okay, great. So, when we think about the climate and the environmental question, it's always fascinating that one of the things that really triggered the modern environmental movement is the famous photo by Bill Anders taken on Christmas Eve in 1968 from the Apollo 8 lander, where he turned the camera back onto the moon's surface and into the picture of Earthrise, one of the first times we saw our planet in our biosphere from an external perspective. And 1968 is a really interesting year because it's the year before the internet was established. The ARPANET arrived about 9 months later. That was a precursor to the modern internet, and it's about 3 years before the Intel 4004 microprocessor, really the first commercial general purpose microprocessor, was launched on the market, which then brought with it the computer revolution. And so this connection between space and our understanding of our environmental predicament and fragility and the strength of the planet is a very, very important one. And it predates many of the very helpful technologies that enable some of the use cases that the previous speaker brought up. In the work that I have been doing over the last 5 years, I've been looking at how there's a pattern of technologies, a set of general purpose technologies that are improving at exponential rates. So unlike the diesel engine or the coal-fired power station or many other technologies, we have technologies like silicon chips, like photovoltaic arrays that improve on a price performance basis at double-digit rates, 10, 20, 30, even 40% per annum over a long duration, a compounded period. And it's what gives us what I call the exponential age. The exponential age being one where some of the fundamental industrial inputs that we are contending with are improving very, very rapidly. And in the context of space, it's been extremely impressive. If you go back to 1981, when the space shuttle first launched in its first two-man mission, launch costs were per kilogram for low Earth orbit were approaching about $80,000 per kg. And of course, in recent years, they are trending down and sometimes below a couple of $1,000s. And that's incredibly impressive. But alongside that, we have seen also through some techniques that emerged from the computer industry that I referred to earlier, the arrival of much smaller and cheaper satellites. I mean, I think about the move from the very, very large and powerful satellite platforms that were running into the tons, thousands of kilograms of weight, through to CubeSats, which run into, perhaps a few tens of kilograms or even lower. The interesting point about the CubeSat and its connection with the rapidly changing technology industry is, of course, to do with standardization, componentization, open source, and the willingness and ability to use standard components from other parts of the industry. In other words, to take a dividend from the success of technological development elsewhere. And I think one of the consequences that we've seen, that I'm sure the audiences are very, very well aware of, is a vast increase in our capabilities, the number of satellites we have circling the Earth, pointing their cameras and other instruments back at the planet. Looking at the number of nanosats or CubeSats that were launched only 20 years ago, we were looking at about a dozen a year. And in 2019, we're looking at nearly 1,500 new launches of these devices, constellations run by, interestingly, privately held companies. And I think that is one of the things that has really tremendously revolutionized the way in which we're able to use the resources available in space to our benefit. The arrival of these technologies that rapidly improve the know-how from the computing industry has pushed down the price of putting a pair of eyes into space. And with the price going down, a number of use cases has increased dramatically. And so today, unlike 20 years ago, any business thinking about its operations can, for very low cost, get access to near real-time 30 centimeter or 1 meter footage of its physical facilities, and can do things that will help tackle its environmental footprint in some of the ways that we heard earlier. And I think that's really a fascinating moment. What's fascinating is that it's really been driven by the private sector, Planet Labs, Spire, Maxar Technologies. These are the companies that have gone off and driven a lot of this innovation. Amazon Web Services now offers simple plug and play access to ground stations, as easy as spinning up a new web server, provided you give them your credit card details. And that creates a very febrile and fertile environment for there to be much more innovation. So I'm quite excited about the technologies that gave us the internet and the internet industry also being able to revolutionize what we can do in space. One of the areas to look at is where are venture capitalists putting their money? So venture capitalists are sort of a critical funding bridge between technologies that are ready for commercialization and scale, and actually getting them into the market. And in 2019, venture capitalists put in something under $5 billion into space technology companies. In 2020, it was nearly or just over $7.5 billion, a 70% increase. Now, that's still small as a portion of the venture capital industry. It's around 5% of the funds deployed, roughly, but it's a significant increase. And I think what we'll start to see more and more innovation in essentially the ecosystem up in space. Now, the reason this connects back to climate change is just that in order to achieve the use cases that we heard about earlier, monitoring of flood risk, monitoring of fire risk, looking at what's happening to glaciation, helping farmers with precision agriculture and better use of their resources, that requires many eyes in the sky across multispectral imaging, looking back at the Earth and of making this information available at very low cost. And if there's one thing that the kind of commercial entrepreneurial venture capital space can do, is it can drive costs down. So I'm quite optimistic. Things I'm seeing as an investor, though, are now moving beyond imaging when we think about space. People are looking at nano manufacturing in space. These are founders and startups, and also clean energy in space, to see whether the zero-G environment can help in the production of key proteins and enzymes and other things that we aren't able to successfully do as well on Earth. But of course, with any private sector activity, we need to be concerned about the expansive nature of business and the creeping privatization of things that we currently may think of as being in the public domain or outside of the property system or best managed as a commons. And space has often been thought of as a commons. And so one of the things that we need to be cognizant of is how can we take advantage of the benefits of this rate of low-cost innovation and the ubiquity that it provides, while also recognizing that we need to have some form of commons governance rather than a first-come, first-served governance to particularly low Earth orbit, but also further afield. And we need to be able to learn from what's happened with the consumer technology platforms of the internet, of how rapidly they can achieve a scale and a very uncomfortable level of market dominance and then economic and political power. So those are two things that I would be, would raise as things that we need to think of: the governance of innovation within space. The positive message, is that as I speak to entrepreneurs building in the exponential age, in the last 3 years, resolutely, more and more of them are saying, I want to put my resources, my capabilities, and my attention towards solving the climate problem in whatever way I can.
Those are quite a number of elements that you gave us to think about, and very important and very interesting. Thank you so much for your contribution. It was a pleasure to hear you so fluid. It was really, really nice. Thank you so much, Azeem. Well, we continue, and I invite you to stay and to listen now another speaker. Before that, I have to warn all the audience that you can leave the questions you have, some comments, the doubts you want to, or the questions you have want to see answered by our speakers in the chat. So you can write us your questions, because after this block we have quite an amount of time to answer to all your doubts, and it's very nice because it's from the dialogue. It's because of this fluid conversation that we can really achieve some answers for our things. So the dialogue, it's primarily really the key to develop and to discover ways of living and ways of to find a solution for everything. Therefore, I now invite Carlo Buontempo, PhD in physics and at University of L'Aquila in 2004, before moving to Canada for his postdoc and then joining the UK Met Office. Carlo worked at the Hadley Centre of Climate Science and Services for almost a decade, where he led the climate adaptation team and the climate service development team. After a number of projects in climate area, he is now director of the Copernicus Climate Change Service. So, Carlo, this conference for me, it's an exercise of accents. So hopefully I was right on yours. Name Carlo Buontempo. Welcome to this conference. It's a pleasure to see you and to hear you now.
Thank you, and your pronunciation was spot on, and I'm really pleased to be here with you. I'm delighted to take part in this really very timely conference, and I would like to just touch on a few key elements that I think represent some of the challenges that we face today. I'm not quite sure whether I put together a few slides, but they don't seem to be moving. But it's not too much of a problem. I can talk even without those. There are three elements I would like to focus on today, and they represent three key challenges that we are facing. The first one is climate change. We heard about climate change already.
Carlo, sorry to interrupt you. Sorry so much, but we now have a technical problem. We're not. You cannot change because you have something to show us, and this machine it's not being able to control. So we have a small problem right now. You have something to show us, and I think you should ask for the control of this display, right?
Yeah, but don't worry, it's okay. I think I can do without. I think
if you have it on paper, you can do it like this, the old school method, right?
Improvisation is part of the job, so it's absolutely fine. I can go without. I was saying there are three big challenges that we face today. The first one is climate change, and we heard from Patrick at the beginning about some of the key challenges associated with climate change. And when we think about climate change, we typically look at the warming temperature. Some of these plots have been made by us at the Copernicus Climate Change Service, as by any other big program on climate. But there is so much more in that. So what we've seen in recent years is really a shift from more traditional climate science towards the application of climate data and climate information to specific contexts. So if you look, for instance, at energy, energy now requires a huge amount of climate data to operate. And I'm talking about the installation of wind farm, for instance. Where do you want to site a wind farm? Where do you want to site a solar farm, and the like? if you look at other sectors, such as, for instance, finance, that you don't normally associate with climate, well, finance is experiencing a significant and rapid increase in the use of climate data. Initiatives such as the Task Force on Climate-Related Financial Disclosure demand all financial institutions to disclose their climate risk. And in order to identify those climate risks, then you need climate data. So I would like to put under this big challenge of climate change actually a number of different aspects. One is the really understanding the climate around us. And another one is translation of this understanding, the translation of this data into specific sectoral applications, sectorial requirements. The second challenge I would like to focus on or to mention today is the challenge of big data. Again, I'm using keywords that are quite common and you're familiar with. Oh, I can see that now part of the slide appears on the screen, so that's great. As you see, the second of this petal of this flower of challenges is really big data. And when I talk about big data, I really mean big. So if you look, for instance, at our use base, we at the moment, as a climate change service of Copernicus, we have some 80,000 users. And to those users, we deliver daily some 100 terabytes of data, which means summing up to petabytes within a couple of weeks. Now, a petabyte is a huge volume of data. Just to make sense of it, think about a stream of music in MP3. Well, it's roughly 2,500 years of music, so quite a lot of music. And we generate that in just a space of a couple of weeks. Now, with that volume of data that can be generated from satellite easily, but also from models, you need to have an appropriate mechanism, an appropriate interface, an appropriate IT system to deal with. Our most popular data set, that is a reconstruction of the climate of the entire planet back to the 1950s and only with 5 days from present, is in the order of 10 petabyte or 8. So really large volume, and you need that infrastructure. So as a climate change service, what we did was to develop an infrastructure that we call the Climate Data Store, and that was mentioned in his introduction by Patrick, as a mechanism to map this petabyte of data into a few kilobytes of usable information, usable by legislators, usable by business or citizen. And we do that daily as part of the service. And for instance, tomorrow we will release the European State of the Climate Report. And this is an exercise in this transformation from data to information. You will find tomorrow a number of indication on what has happened to glaciers, to sea ice, to vegetation, not just temperature and precipitation, but all variables that build up the climate system. This brings me to the third challenge, and the third challenge is very much the fake news, if you want. So, in a sense, we are asking society to adapt to climate change. We're asking society to rely more and more on this huge set of data that the satellite and the model make available, and still, there is a bit of a leap of faith, because how can you trust that the information we provide is trustworthy? Ultimately, it's a bit like COVID, right? You hear information about the R number or the number of people infected from different sources, and there's like difference. And which one do you trust? Well, after some time, I guess you learn and you got used to some supplier and you trust them more. But ultimately, what builds that trust is information about the quality of the data you're receiving. So within the Copernicus Climate Change Service, we put an unprecedented effort in enriching each data set with sufficient quality attribute to allow any of the user to make sense and to judge whether that specific data set is appropriate, is accurate, and is usable for a specific application. And now, this is what has been done by us over the last course of the last 5 years. But the three challenges I mentioned, so climate change, big data, and if you want fake news, so attributing quality to the data set, I think are challenges that are much broader than any specific program in isolation, and are challenges that our society face. And so those require a solution. So we paved the way in some sense, and we pioneer some of these elements, but the answer to these challenges is something that we need to find collectively. One last point, and is an important point, and is strictly and strongly linked to the Copernicus program as a whole, is the importance of maintaining an open data license. So all the data I talked about that can be reached on the Climate Data Store, all the data that sits behind the State of the Climate report that will be released tomorrow is available publicly. So this is another way in which we build trust, is the ability for anyone, not just scientists, but any citizen, any interested person, to look at what has been done and trace it back to the fundamental ingredient and check by themselves whether what we are saying makes sense. So there is the famous motto of the Royal Society that is nullius in verba. I don't trust anyone on his word. And I think that's very much linked to the skepticism of any good scientist. And I think this is an important element, and we would like to ensure that all we say is transparent and traceable back to the original data and tools used. Thank you very much for your attention, and I look forward to the discussion.
Thank you so much. And this is quite a sensitive subject, fake news. I think that's one of the greatest enemies of scientists, how to create this faith, this belief in people when we have so many fake news surrounding us and blocking the way for the truth and to the explanation of things. Yes, absolutely. So we follow our program and connect now with Suzanne Mecklenburg, Head of European Space Agency Climate Office. Susanne is responsible for promoting and increasing the use of satellite-based Earth observation data in climate science. Her current focus is the delivery of ESA's Climate Change Initiative program and developing future program activities with ESA Climate Office as the focal point for climate. Welcome. You have what we call the big picture, right, Suzanne? You can see, you're in the place where you can see the big thing, right?
Yes, thank you very much. Can you actually hear me?
Yes, we are.
Yes, perfect. Thank you very much. I had a few slides. If you wish, you can bring them up, or otherwise I will, like Carlo, just
yes, I think we can see your slides. Yes, we can. They're on my left side and we can see them. Yes, thank you.
Okay, very good. Yes. Maybe as an introduction, I would like to say that in the ESA Climate Office, we come a little bit from another angle than my previous speakers. We've heard from the policy side, we've heard from the operational service side, we've listened to what Azeem had to say on types of innovation. We're coming from a perspective of science, of scientific research, of R&D, and of pre-development for operational services. Maybe just to explain a little bit who we are, if you can go to my second slide, please. The ESA Climate Office is located in the UK. We are the focal point for climate activities in ESA, and the main activity that we actually do is we address the quantification of essential climate variables, ECVs we call them. So these are indicators how our climate is actually changing, and so far we've addressed most of the ones that you can actually do when using space-based data. And we're working very closely with the Copernicus Climate Change Service, where Carlo is the director of this one. There's the international, let's say, climate network is a very big one. It has many players. It has many players in the sense of with different interests, requirements, and expectations of what we can actually provide. I see our role very much as an agency and a possibility to add to the important evidence base that we need to have to actually be able to address climate change. Any policy, any decision that we will take in terms of mitigation or adaptation, we will have to take on the basis of knowing what's actually happening at the moment and projections into the future using climate models, for example. And this connection is very, very close to our heart in ESA as well, to make the connection between the Earth observation provision of data, the climate data records as it is, but also working with the climate modeling community very closely to make sure that they actually can use these data to verify what they can actually project, what they can predict, and the quality of which and the uncertainties that come with that, but also to improve the models themselves. Could you please go to the next slide? Listening to Carlo, I sort of wanted to also make a point in what I see at the moment as one of the main challenges that we need to address from our point. Coming from the scientific perspective, I think there's a couple of events taking place and over the next number of years that we will need to address. One is, of course, the uptake of this scientific evidence in the likes of IPCC, the Intergovernmental Panel for Climate Change assessment reports. These come out every number of years, and they give a summary of what the most pressing points in climate science are at the moment and what we can actually say with certainty. But these are basically translated into policy decisions, and the main overarching policy decision, let's say on a global level, of course, at the moment is the UNFCCC Paris Agreement. And under this Paris Agreement, all the participating states have signed up for that one, which is almost everybody, will have to report their individual emissions, which you can basically divide into two main lines of saying, basically the emissions itself, greenhouse gas emissions, but also the AFFLU, what we call AFFLU, which is agriculture, forestry, and other land use information. And precisely on these reporting requirements for our member states and for anybody else in the world who wants to use our data, I think one of the major challenges is, for me, the translation of these policies into what we can actually provide also from space to help them. So, we need to work in the future very closely with national authorities who do this emission reporting and take decisions about mitigation and adaptation so that they can actually use our global climate relevant data sets for their reporting and for the improvement in an overall world of change. And that is something that I see as one of the major steps that we need to address between now and possibly 2023 for the first global stocktake, and definitely until 2028 when we have the second global stocktake. It's we started working with the national authorities and understanding how we can actually tailor our space-based climate data records to their needs. And this is not a simplistic discussion to be had, given how multi-layered this reporting process is in the sense of what data is required. So we will have to continue this dialogue, and that is one of the main challenges that I see from our side, and how we will develop our climate activities in the European Space Agency in the future. And it will further translate into regional and national requirements, like, for instance, the aspects being addressed in the Green Deal, as we've heard earlier in this session already. So this is quite a network of different interactions that we need to have, from science to evidence-based to operational services to translating it into policies, in reinforcing policies, and then possibly coming back again to the evidence base to update all this process in itself. So it's a bit of a food chain of climate change policy, I would think. And I'd like to sort of finish my presentation with my last slide, just to give you a tangible idea of what it actually means to produce these data. If you go to my last slide, you will see a global map of above ground biomass. So this is essentially quantifying what the amount of biomass that we have on the planet. And as you can see here, you can clearly, of course, already pick out the Amazon forest and the tropical forests in Africa. This is something that only came out recently. We are producing these annual maps now of biomass, and that's very important in a sense because that will be one of the information that we will need to also report against the Paris Agreement in itself. These maps are basically made by different means of data. They combine data from different satellites and sensors, and that needs partly very important amounts of data processing power in itself. These data are very useful for sort of strengthening our scientific understanding of the global carbon cycling and improving also the climate models. So it's that aspect also needs to be reinforced as well. And they support forest management through the UN RED initiative. Definitely, there's more work to be done there, but having this particular knowledge, just to give you one example here, is important to understand the sources and sinks as well of CO2 in our atmosphere. So I think, just to summarize, my biggest challenge is I think the large amount of very valuable spaced data being available into something that not EO, Earth observation experts can actually use in their daily work to address the effects and the impact of climate change. And this is something that I see as one of the major challenges for us to address. So thank you very much.
For your contribution. It was quite easier for us to understand some of what you were saying and explaining with these displays. Thank you so much. So Helena Martins, our next guest, she's a Portuguese investigator, no longer in Portugal, right? Helena Martins has a PhD in Sciences Applied to the Environment from the University of Aveiro and a Master of Science in Economics and Policy of Energy and the Environment from the Technical University of Lisbon. She's now in Sweden, as I said, to work as science communicator at the Rosby Center, the climate modeling research unit at the Swedish Meteorological and Hydrological Institute. Welcome, and in Portuguese, bem-vinda.
Obrigada. It's a pleasure for me to be here today. Really a joy to join this panel and talk about understanding and preparing to address climate change. And this might seem at a first sight a bit strange. Okay, I'm a science communicator, what am I doing in this panel? But really, when we are trying to understand and prepare for climate change, we really have to talk about it. It's like the first step. If you could move on to my second slide. Thank you. So we have this huge challenge ahead of us. We have this goal of keeping global warming well below 2 degrees, preferably limited to 1.5. And as this graph shows, I hope it works. Maybe if it's clicked from there, we can show how the global temperature average has been increasing since the beginning of the Industrial Revolution. Well, if it doesn't work, let's move on to the next slide where you can see the lines already being drawn there. So what we can see, hopefully, yes, there it is. We can see that we are getting daily or very fast pace, getting close to these 1.5 to our goal. So to get there, we have to decrease our CO2 emissions rather quickly in the next years. Next slide, please. So this is a huge challenge, and we need to take action to fight climate change. And the word here, the key word really is urgent. We don't have time to do it. So we need research and we need innovation, as we saw here today, to tackle this challenge. But we need a societal transformation. So we also need, next slide please, science communication. So science communication can empower research and innovation to fill its full potential. But we cannot do it just anyway. We have to be very scientific about our science also. And yes, we can move on to the next slide. So if we are so methodic in our research, if we follow the scientific method when trying to understand the natural world, why do we rely on our intuition when it comes to communicating it? Why do we still rely on these old practices and this old-fashioned idea, but that sticks really hard to us? That is, okay, the problem is that people don't know. We just throw the knowledge at them, and that will solve everything. Next slide, please. And so if we tell the people, you're wrong, let me correct you, let me tell you why I'm right, why I know better than you, that simply doesn't work. And we know that from experience. Next slide. And this is particularly true in these times that we are living now. These times where we live in a post-truth politics, where politics is much more connected or tries to connect with people's feelings and not so much with reason. And in this time of post-normal science, what is this post-normal science? It applies very well to climate change, but also to, for instance, for COVID-19 and vaccination. So we are developing the science as we go and as we are moving, and these challenges arise. So the facts are uncertain. We are not completely sure about the consequences of climate change, about the best or about the exact mitigation measures that should be applied. Also, there are values in dispute, because a lot of this climate change discussion and problems, it has to do with solutions. So people are not okay with some solutions. They go against their values. Stakes are very high, meaning that if we fail to address this challenge, there will be severe consequences. And decisions are urgent. We have no time really, so we have to act. This is true for climate change. This is true for COVID-19 and vaccinations. And so to address this in an effective way, we have to turn to social sciences, the cognitive sciences, who have done a lot of work in understanding how the human mind works and what works well in terms of communication and what doesn't work so well. Next slide, please. Yes, so what does science tells us, this natural sciences? First point is kind of obvious. We have to know our audience. Yes, obvious, right? But sometimes we forget about it. And and this is vital. We talk about talking to the general public. There is no such thing as the general public. So there are lots of groups of segments inside this general public. And they have different perceptions, different views, different morals, different political understandings. And so we have really to establish a connection to them if we want to have a chance to succeed. And for instance, we don't talk to conservatives the same way we talk to liberals or to environmentalists about climate change. If we approach conservatives with the usual arguments, I'm listening some feedback sound, I'm sorry. So we shouldn't come to them with data, we should come to them with talk about, for instance, our health, they maybe don't think that fossil fuels cause climate change, but they know that it causes pollution, and so that it is harmful to them. And so maybe through that point of view, we can get there. Also, we have to tailor our message to the audience. So we don't talk the same way to everyone. And this is a book for children about climate change, written by the climate scientist Michael Mann. It's certainly very different from what he writes into the IPCC reports. And so we can tailor the message to our audience. And there is this belief maybe that we cannot reconcile church or religion with science, but we can approach religion, the topic of climate change, by appealing to the values of not only focusing on climate change as an environmental problem, but also as an humanitarian one. And then, okay, we know our audience, we tailor the message, but if we can turn the message into a good story, then the chances of succeeding are great, are much bigger, because it all comes up to telling a story. And a good story really tells more than numbers, tends to stick more. It's more appealing. You tend to remember stories better than simple facts and numbers. And so if you use images to tell your story, that also works very well. So yes, there's a lot to do to improve science communication. We have to feed on this knowledge from the behavioral, social sciences, and we have to abandon old practices that don't work. But still, it comes, and now I'm going to touch a topic that Carlo also touched about misinformation and fake news. Because when it comes to dealing with complex problems, we don't, many of us, we stick to our beliefs, to our values, and not so much the data. So no matter how much data we show the people, they choose not to believe it, and they turn to those who think the same way that they do. No matter if they are reliable, if they are credible or not. And so really, misinformation is, as Rita also said, one of the biggest challenges that science faces right now. And we have to address. You have to understand where this misbelief in science comes, where this mistrust from science comes, and address its causes. So we might tend to cover our eyes and our ears and pretend we don't see. Maybe you cannot see it. It's rather small, but you don't see certain tweets from certain important people who have responsibility and who deliberately misinform the public and their voters, or to journals, to newspapers with big circulation numbers that deliberately, purposely feed false claims to people. So, and ignoring them doesn't work. It only gives them more space. So we have to act. We have to open our eyes and our ears and our mouths, because again, social sciences has shown us, has studied this and has figured out every science denialist is, or science denial campaign or misinformation works. And so by knowing how it works, we can really fight it. And again, a parallel with COVID-19, a technique that seems to work against misinformation is inoculation. So like in a vaccine, you give the population a weak version or part of the virus, and then the population develops immunity, and then when facing the real virus, we have this immunity and we can resist it and fight it. And this is the same with knowledge. If we warn people about the strategies, the techniques that misinformation uses, I think we can be successful in identifying it, because we are not all experts, of course. We cannot, in any conversation or reading a news or reading a book, we cannot have a group of scientists from all areas telling us this is right, that is wrong. No, but we can look at the techniques which are basically the same, even if you're talking about climate, if you're talking from vaccination, genetically modified food, etc. And it has a lot to do with these 5 characteristics. So, for example, fake experts. You see an expert who is talking about some topic, but then when you check, he's not really an expert, or he's an expert in something else. Conspiracy theories, impossible expectations, like expecting to be 100% sure about the vaccines being 100% effective, for instance, or knowing everything about the climate and how it works. So and this is very important, and I'm just finishing, with our kids. So we teach our kids, we educate children to be aware of dangerous strangers, for instance. We can also teach them to be aware of misinformation. We can also teach them some of the points that they should look at to try to identify if a certain source of information is reliable. And so I come to the end of my story. I don't really have a conclusion or a beautiful ending. I'm just happy to share a bit about the simplicity of talking about climate change and the need to do it, but how complex it is. Thank you very much.
Thank you so much, Elena. Very interesting, the parallel between a vaccine and the knowledge. growing from a small parts and taking a bunch of people. Fortunately, we hope we hope for that. Thank you so much. Now it's time for some questions from our audience. But first, I have a question for Patrick Child. Are you still with us? I can see you here.
I'm here, yeah.
Yes.
Happy.
I have a question for you. You mentioned the pandemics and space programs. How can Copernicus contribute to the pandemic's recovery? I know it's a hard job to do.
Yeah, I mean, I think it is a difficult and somewhat indirect challenge, but I think that the experience that we've shown about the sort of data that we are able to gather, looking at how sort of trends. I talked about the example that we've been developing in my remarks of a vector-based spread of diseases that can be monitored from space, which is a program that we had put in place even before the present pandemic. I mean, is an example of that. I think that the bringing together also of different data sources. I mean, we have emerging data about the medical consequences, the demographic implications of the pandemic. And if we can bring that together with the information that we gather from our broader Earth observation from satellites, from space, I think that we can learn important lessons and deepen research and deepen our understandings of the broader trend of the spread of the pandemic, and also equip us better for in future preparedness against future pandemics. And I think that those are the sort of areas where I'd like to see us working more in the combining different areas of research, different instruments and solutions, including space assets, as we take forward our new programs under Horizon Europe and work together on the very necessary sort of green and digital post-COVID recovery strategy.
Thank you so much, Patrick. The next question comes from the audience, but now for Azeem Azhar. We have, several questions, I have to say. First of all, the exponential age, how do you envision the use of space technologies, namely to the benefit of the common user, to the benefit of business for the daily use?
Yeah, I mean, I think it's a really important question, and one that I hinted at, that space right now has a sense of being a commons, a public space for the benefit of all. And I think one of the things that we need to work on is how do we ensure that space does not get privatized in the way that other aspects of the digital realm have been privatized. And one small example of that is, the current standard of light pollution as a consequence of the Starlink constellation launched by SpaceX, which has, is very disappointing if you're an amateur astronomer, for example. So I do think there's more governance that's required. But on the other hand, the one thing we do know is that these technologies will drive very, very fast down in price. So things that we think only large-scale institutions can do today, like measure the rates of deforestation or engage in precision agriculture, could become very, very commonplace even for small-scale farmers, and then that would flow through to more effective resource usage and better pricing, even in local economies wherever they are in the world. And that would just be one example.
Well, you mentioned the business growth. It is a factual expected reality and captivating for entrepreneurs and investors?
I have seen in the last 5 years growing interest in amongst entrepreneurs in the space area. I think that the success of SpaceX has given people a story. We heard about the importance of stories just a few minutes ago, but also the success of Planet and Spire. Spire, I think, is actually listing as a public company very soon. And in fact, when I now look at space technology companies, there are many dozens of startups in areas as diverse as remote sensing and connectivity, as well as in launcher technology, which is obviously of a much larger scale, but even downstream in terms of lowering the cost of ground terminals and communications technologies. So there is an ecosystem of innovation that is emerging right now that I think we'll start to see having real benefits as they mature in the next 5 to 10 years.
Martin also have a question for you, Azeem. Fantastic insights, Azeem. Well, first he has something nice to say. And now, could you elaborate on how Europe can convince other world powers to advance a commons-based governance in space?
I think that Europe has a really important role to play as one of the poles in between the Chinese pole and the American pole of geopolitics. And Europe has the benefit also of being very rights-driven and very humanistic in its approach of finding a balance between technology and innovation and society and citizen concerns. And I also think that Europe has established that it's not sufficient to simply drive through on the profit motive. So my hope would be that we would build on the successes that we have had with data privacy, digital privacy in the digital realm, and be able to build on that and actually present frameworks that make sense. And one of those critical frameworks is that we don't need to privatize every aspect of this domain. And that starts, I think, with some of the efforts that are coming out around harmonizing digital tax, which is, again, in a different realm, but it can the principles transfer across.
Next question is from Carolina Sá and for Helena Silva. And she said, very interesting perspectives on the challenge of communicating mentioned in the panel, and the importance of communicating the uncertainties of the data to avoid fake news. Is it a double challenge? How accurate are the uncertainties and how to communicate them, Helena? You have to connect your microphone. Yes, now it's okay. Thank you.
Okay. The communication of uncertainties is a whole topic for itself. It's something really complex and difficult for climate scientists. And uncertainty, starting in the word itself, it doesn't mean the same thing to everyone. For climate science, for a non-climate or non-scientist person, uncertainty can be perceived as, okay, you don't know. You're talking about uncertainty. You don't really know what you're talking about. You're not sure about that. And that is not what happens. And then, of course, scientists love to talk about uncertainties because that's what science is all about. It's about finding out what is still not known. So it's part of the work of a scientist. And sometimes we have my colleagues, I have to kind of kick them to stop talking about what they don't know because people maybe are more interested in what they know. And so that doesn't mean that we don't speak about uncertainties. That doesn't mean that we are not clear about it, that we are not transparent about it, that we are open about it. But when it comes to climate change, there are a lot of things we still don't know. We don't know exactly if we have different paths we can follow in the future in terms of emission. And this will have different outcomes. We have natural variability in climate, which we will never be able to fully predict and to know. So we have to guide ourselves also by the precautionary principle, because this is urgent and we don't have time to know everything before we act. So we really have to act, although we don't know everything.
Thank you. We're running out of time, but we have time for two more questions. One for Carlo Buontempo and another one for Susanne. First of all, Buontempo, Copernicus and data is one of the highlights of your presentation. How do you see this program contributing to the Earth Observation Center that was formally launched yesterday?
Well, it's very good question. Thank you very much. And the Earth Observation Knowledge Center was launched yesterday. Is basically based and build upon the experience of Copernicus and the Copernicus services. It really will play an important role in the interface between the services and the policymaker, and understanding what the requirements of the policymakers are, and bring back those requirements to us to ensure that what we deliver is really fit for purpose. So the two things go hand in hand, and I don't think one can exist without the other, really.
Thank you, Carlo. And now, Susanne, as this climate change initiative is vital for climate sciences, would you like to elaborate to the way, or the ways ESA infrastructure can be a valuable instrument to today's approved at the European Union climate law?
So you were breaking up a little bit. Could you?
Yes, I'll repeat. As this climate change initiative is vital for climate science, would you like to elaborate on the way this as an infrastructure can be a valuable instrument to today's approved European Union climate law? Because it was today.
Sure. I mean, no, and I think it's not the only one that it could actually provide the
yes,
the
it's true.
underlying
It's true.
of the changing climate. I think we are basically using a subset of space observations for creating these climate data records. They are by no means all of them available. I think it's the combination between, for example, what we are doing, what C3S is doing, and what UNITSAT is putting together. And I think they are basically the underlying base of scientific evidence for drawing up the activities in response for these policies, international and national and regional.
Thank you, Suzanne. Thank to all of our speakers for their sharing of knowledge and information and experiences. This is why this is so important to do this conference, the richness of all of you. It's brutally important. So thank you so much for all the audience. We're going to make a short break. Usually we say that this is the coffee break, but the pandemic and all the distance avoid us to mingle and get together. So at your homes, at your local of work, everything, take a coffee, come back in about 10 minutes. See you then.